Some of them at UB last year.
Who did? Oh, big homie right there.
Mm-hmm.
I think I know of her.
Oh.
You look familiar. Slender Man. Cody. Here, Jason and Maddie still here? You guys know them? Soccer players? No? Good, don't talk to them.
Okay, 8:30, 18. So these IM3 teachers, I don't like how they name stuff. They literally named it K times f of x. Not K times f of x. Probably like change, I don't know, something different. Oh, no. All right. You good?
Yeah. It happens more times than you think it would.
Today's the 30th. What page did I say? 20? Okay, thanks. Central question. What does K do to the function? What does K do to the function? Miss Donahue, you can move anything on my desk that's in your way. That's in your way. Like, okay. Like the
Okay.
Mm-hmm. Dying. Now, I'm putting the time sign just so you know that we're multiplying, right? It's not k f of x. Like, it's k times f of x. So we need to know what the k is doing. This k, did you ask a question? Oh, okay. Is the same as a in front of every function. Sebastian, for your glasses. Yeah. So it's like a in front of every function. So I like to take you back to what you remember, hopefully. When you were in IM2 and you graphed a parabola, right? You would answer the question either narrow or wide, or in my class, skinny or fat, right? Do you remember this question? What made it skinny or narrow? When A was what? Do you remember? Fractions make it fat. Can you get that over, please? He left his bag here too. Fractions make it fat. Whole numbers make it skinny. So the way it works is this. Your bag's over there. If the absolute value, in other words, it doesn't matter if it's positive or negative. We just want to know if it's a whole number, so greater than 1, you have a narrow, or you can use the word skinny if that helps you remember, function. Okay? So absolute value of A is greater than 1. So in other words, a whole number, right? Usually it's just a whole number. Now, I say whole number, but could it be like 1.5? Yes, technically that is still greater than 1. But for the most part, we usually use whole numbers like 2, 4, right? We're not really using like 1.5 or 3 over 2. We can, but it's usually not always. So in other words, just bigger than 1. Okay? we have a narrow or a skinny graph. If skinny is easier for you to remember, that's fine. Now, if you take the absolute value of A, and it's between 1 and between 0, it's wide. So in other words, if it's a fraction, with the exception of improper fractions. Why the exception of improper fractions? Because if I give you an improper fraction of 3 over 2, is 3 over 2 located between 0 and 1? No, what does 3 over 2 mean as a decimal? 1 point what? 1.5. So if I have 1.5, that's back to up here, right? Bigger than the 1. So if you want to make a note that bigger than 1 also can be your improper fractions, that helps. Improper fractions mean that your numerator is what? Bigger than your denominator. Good. And if you get the absolute value of A, it's just plain old 1. It's just the same. Nothing's really happening to it. We're going to use some tables today to prove. So today, in our tables, do we know what a table is? A table is an XY value. Yeah? Okay. So we're going to use tables today. In our tables, we're going to use the points -1 for x, 0, and 1. For all the functions, but there's one exception. Except square roots. For square roots, our table, why do you not want to take the square root of -1? Because it's negative, and then you have to have imaginary, which is I, right? So for square roots, we don't want to deal with that. We're just going to do 0, 1, and 4. Why 4? Usually, it's even. It's usually a what? Perfect. It's a perfect square. Is 1 a perfect square? Yes, the square root of 1 is 1. Okay? Make sense? So this is pretty much everything except the square roots. Square roots use this one. First example is f of x equals 2 times x to the third. F of x equals 2x to the third. Okay, what's our a term? What is it? I heard it. It's 2. The absolute value of a is what? What's the absolute value of 2? Still 2. Is 2 greater than 1, less than 1? Greater than 1. So is it narrow or is it wide?
Wide. No,
Narrow. Good? Okay. We are going to graph it, but before we actually graph it, we're going to make a table today. Okay, we're using -1, 0, and 1. Why are we using -1, 0, and 1? Because they're what? What kind of function is this? What kind of function is it? Is it exponential? Is it a cube root? Is it a square root? Is it absolute value? What is it? It's a polynomial. What kind of polynomial? It's cubed, right? What does the polynomial graph should it look like when it's to the third power? What kind of S? Is it laying down S or is it up and down S? Is it like this or is it like this? It's up and down. So it should be, oops, that's a really big, something like that, right? Okay, but before we do that, we need to figure out our points. So what are we going to do with negative 1? What are we plugging it in for? For x. So we're going to do, I'm going to move my y over. I don't like y there. I'm going to do f of negative 1 equals 2 to the negative 1 to the third, right? I'm going to move that y value over. I don't like it there. What is 2 to the, what do we do first? Do we multiply or do we do the exponent? The exponent. So what is negative 1 to the third power? Negative 1. What's negative 1 times 2? Negative 2. So what's the point we're graphing? Negative 1 comma negative 2. So let's go graph negative 1, negative 2, which is down here. All right, what's the next point we're graphing, or what are we plugging in next? 0. So f of 0 equals what? 2 times 0 to the third. What's 0 to the third? What's 2 times 0? Wonderful. So graphing 0, 0, which is the what? Origin. What's next? 1. F of what? F of 1 equals 2 times 1 to the third. What do we do first? Exponent. So 1 to the third is what? 1 times 2 is 2. Almost looks like a line, but it's not going to be a line, right? Make sure it curves. The other thing I saw is that instead of curving up, I saw this, watch. Curve like this. Do you see what I just did? I'll do it in pencil, hold on. I saw this on the quiz. They started this side looked good, and then they went like this. And it like went really flat for a really long time. Is it allowed to go flat? No, it has to grow really fast. Okay? So if you went really flat, no, I may have taken off like half a point. It's got to curve up fast. Is this an even or odd function? Odd. How do you know it's odd?
Because it has a 3.
Has a 3, but what else? What are the requirements? 3 is the start point. Goes through the origin. What else?
Oh,
The reflective points. Good. So we started with negative 1, negative 2, and we reflected 1, 2. So remember, this point is the opposite of this, and this is the opposite of this, so then it works for our odd. True? Domain. We need to list domain and range. These are easy. What's domain? Negative infinity to infinity. What's your range? Negative infinity to infinity. Good? I'm going to give you one to start. You can talk to your partner. Decide what type of function you have before you go do anything. Because if you don't know what kind of function you have, your table determines. Yes? Because if it's a square root, you want to make sure it's a square root. If it's not a square root, then it doesn't really matter. But determine what kind of function you have first. F of x equals negative 1/2 square root x. Decide what kind of function you have. Once you decide what kind of function you have, decide what your table is going to look like. Check with your partner to make sure you're on the same path. Decide what your function is and decide what your table is going to look like. Sebastian, put your phone away. What kind of function? Square root. If it's a square root function, it's a falling star. Why is it falling? Because it's negative, so falling star looks like this, yes? Okay, it's just a little sketch. Now, does the chart matter when you have a square root? What numbers are you picking? 0, 1, and 4. Very good. So let's plug in 0. We get, f of 0 equals negative 1/2 square root of 0. What's the square root of 0? 0. Times that by 1/2, negative. What's your answer? 0. Good. When you plug in f of 1, you get negative 1/2 times the square root of 1. What's the square root of 1? 1 times that by negative 1/2. What do you get? Negative 1/2. F of 4 equals negative 1/2 times the square root of 4. What is the square root of 4? 2. 2 times negative 1/2 is what? Negative 1. Very good. Okay, we need to decide. Did you say this was, oh, we didn't write it. What's our A? What's A equal? Negative 1/2. Does that make it narrow or wide? It makes it wide. Why is it wide? Because it's a fraction. Or like I like to remember, fractions make it fat. Right? You can remember fat fractions? Fractions make it fat. So it's a fraction, it's going to be wide or fat, whichever way you want to call it. Let's graph the point 0, 0, which is here. 1, negative 1/2, which is about here. And then 4, negative 1, which is down here. Go ahead and identify domain and range and talk to your partner next to you. Make sure you have the domain right and the range right. The reason why you pick -1 is you want to see what happens on the other side of the y-axis. Because if we just do 0, 1, 4, we're only in the first quadrant. Do you understand?
But why didn't you just decide to set up the other one?
Because we said on the other side it's a square root. And remember, you told me that we can't take the square root of -1.
Is the card still same?
What's up? We wrote that down. Good? What's your domain? 0 to infinity. Infinity gets a parenthesis, 0 gets a bracket. Very good. Range. -infinity to 0, parenthesis, and a bracket. Very good. Question there? All right, let's do another. Let's see how much you can do by yourself. You can check with the partner too. F of x equals -3 times 2 to the x. Oh, 2 to the x. What kind of function is it? Exponential. How do you know it's exponential?
Because it has to.
Your x is your exponent. Check with neighbors. Check.
Dan, do you watch Orange is the New Black? You know Crazy Eyes is? Crazy Eyes. I'm tired of it. I'll show you. You tell me if I should be hurt. You know who Mackenzie is, right? Mackenzie?
Ready? Okay. All right. First of all, you said it's what kind of function? Exponential. What is exponential going to do? Is it shooting star? Is it like a curve? Is it a U? Is it a V? What are we? It's like this, yeah? One of the two? So regular exponential just does something like this, yes? I know that's not what it looks like, but just so we know. Has an asymptote somewhere, right? All right. Oh, let me throw it. What's next? A. Let's talk about A. A is what? -3. Narrow, wide, or same? Narrow. Why narrow? Because what? Because it's greater than 1, so the whole number greater than 1. All right, in your chart, what numbers are you picking? 0 and 1. How many of you got stuck at the -1? Okay. We'll bring you back to IM1 in a second. What does the negative do to it, though? No, not this. What does the negative do to the function, the graph? It reflects it what? Reflects it down. So make sure we know that. Okay, here we go. We're going to skip -1 for a second. Let's do 0. F of 0 equals -3 times 2 to the 0. 2 to the 0 is what? No. 1. 2 to the 0 is always 1. How many of you remember that? Okay. 2 to the 0 is 1. So -3 times 1 is what? -3. Let's do 1. F of 1 equals -3 times 2 to the first. 2 to the first is what? 2. Times that by -3, what do you get? -6. Good? All right. We'll talk about this one. This is f of -1, which is -3 times 2 to the -1st power. I'm going to do 2 to the -1st on the outside. I'm going to do it over here. Okay, when you have a negative exponent, does anyone remember what you have to do to it? Make it a fraction. Once I make it a fraction, if it's negative and it's located on the top, it needs to go where? On the bottom. When I put it to the bottom, it then becomes 1, +1, with a 1 on the top, because you can't have a fraction without a numerator. So what does this give us? 1/2. So here, you're multiplying -3 times 1/2. What is -3 times 1/2? -3 over 2? Yeah? What is your K? What is your horizontal asymptote? 0. So horizontal asymptote is what? What? X or Y? Y equals 0. Horizontal asymptote at y equals 0 is right on the axis. I just kind of drew it on top. Can't really see it. Graph your points. We have -1 and 1.5, which is located between 1 and 2. We have 0, -3, which is down here, and 1, -6. 1, 2, 3, 4, 5, somewhere down here is right there. Remember, you're approaching 0. Can you touch 0? No. Do you need to be close to 0? Yes. What I also saw on the test was that people made this, their they graphed the asymptote, right? But then they curved this, so it just never go out close to 0, the asymptote. You got to be careful. So it does need to curve towards the asymptote. Any other questions? Do you remember the negative exponents? A little bit? So really quick, negative exponents. If I give you, we just did 2 to the -1. If I give you 3 to the -1, what do you put underneath the 3? What do you put underneath it? 1. Where does this go since it's on the top? Goes on the bottom, becomes 1, and then you get just 1/3, yes? Okay, what happens if I do this, though? Just out of curiosity. 1/2 to the negative 1. What happens if I do 1/2 to the negative 1? Can it be negative? This one here was only to the whole number, right? This is to the fraction. So what do you think happens to the fraction? Reciprocal. 2/1 to the first power, which is just 2. So notice the whole number became a fraction. The fraction becomes the whole number. Do you see it? Your whole number became a fraction. Your fraction became a whole number. So you need to be careful. Make sense? Because more than likely you're going to have something like that, yeah? Which part?
The one that switched the whole
This one? Do you understand this one? Why don't you, what's wrong with this one?
No, I don't understand.
This one? Okay. So my question to you is this. Have you seen, and I know some students have because I do it, what is 3 to the third? We're going to start basic. What's 3 to the third? What does it mean?
3 times 3.
And when I multiply 3 times 3 times 3, what is it? 27. Yeah? What is 3 squared? What does that mean? 3 times 3, which is what? 9. Okay. What is 3 to the first power? How many 3's? Just 1, which is just 3. Yes? Is that a true statement for all of those? Okay. Now, as you're decreasing a 3, remember this is multiplication. So what's the inverse of multiplication? Division. So if I'm looking, 27, if I go from 27 to 9, what operation am I doing with 27 and 9? You're dividing by what? 3. Well, why does that make sense? Because you had 3 of them. You took one away, which isn't really subtracting, it's dividing. So if I divide by 3, I now have 9, right? If I divide 9 divided by 3 again, I now have 3. Yes? Following the same pattern. If I divide by 3 again, 3 divided by 3 is what? 1. Oh my goodness. Well, isn't that 3 to the 0? This is why anything to the 0 power is 1, because you're dividing. Okay? Keep following the same pattern. Oops. Divide again by 3, because we're staying with base 3. So now I have 1. I'm dividing by 3. So that looks like 1 divided by 3, right? But we don't like this. This is like, weird. So how do we rewrite it for us? 1 over 3. Doesn't that mean the same thing? Doesn't 1 over 3 mean 1 divided by 3? True? Okay. So that's the next one. Well, if that's the next one, and look over here, this is third, second, first, 0. So what's the next pattern? -1. So to the -1 power, it means I do 1 over 3 to the first, which then becomes my 1/3. Do it again. Divide by 3. Yes? So you have 1/3 divided by 3. Are you allowed to divide a fraction in a whole number? No. You have to do what? No. Put it over 1 and find the reciprocal. So this goes over 1, and then you multiply by the reciprocal. So this is really 1/3 times 1/3, right? What is 1/3 times 1/3? No. 1 over,
6.
multiply, 9. It's 1 over 9. So that's 3 to the negative what? Second, which is 1 over 3 squared. So if I notice my pattern, these are whole numbers. As we keep dividing, you get to fractions, right? Does that make sense? Okay, so this is with the negative exponent. What the negative exponent does is this is a proof over here. Not because I just told you, you make it a fraction, move it over. right? How many of you have seen this? Yes. Good. How many of you are looking at me like this is the first time you've ever seen this? Lord help you. Okay? So write it down. But if you notice, it keeps dividing. Could I do it again? Yeah. Who wants to guess what 3 to the negative third is going to be? 1 over 27, which is 1 over 3 to the third, right? The negative exponent doesn't make your answer negative. It makes it a fraction. But if you had a fraction, it now needs to make it a whole number. Do you understand? Does that make sense? Are we okay? There's your lesson in negative exponents, including 0. And this is why 0 does give you 1, not because we told you to. Right? There's mathematical proof as why it gives you 1. We good? Okay. You have homework. Shocker. It's a worksheet. I forgot to hole punch. Sorry. There's a whole bunch if you want one. It is just one side. It says sketch it, state if it's narrow or wide, and then find the 3 points. So in other words, use the table. Do you need one more? Yeah. There's not enough time. Sorry, Alex. We'll put your phone away, darling. Go through right now your worksheet. Before you even do anything, what should you probably do? Any guesses? Well, after you put your name. Identify what? Identify the type of function you have. Because if we can identify, we can graph it. If we can't identify, we can't graph.